Okay, so I've got some good news and bad news regarding Refactor Rx. The bad news is it has been renamed to Artifact Atom, which means we have to migrate everything. So there's no longer a concept of an Rx, but instead an atom. And the good news is it comes with a ton of improvements, particularly around working with promises. So what we're going to do first is migrate to Artifact Rx. So what I'm going to do is come here to scripts and then dependency utils, and then here update effect dependencies, and then we are going to rename this to atom. So add effect atom / atom - react. And by doing this, saving this file, I can now come here to my terminal and say pnpm and then effect :update -deps. And actually I forgot to update the reference here in my package.json, so same thing for both the overrides and the dev dependencies. And once we have this, again, we can run this and we get 0.1.6. Awesome. So now this is going to break everything if I'm not mistaken. And whoops, I forgot to update the dependencies for the client. So now we reference artifact atom and then run pnpm install. And as we can see, we get a type error, cannot find module. So actually we're going to change our strategy, and that is we're not going to have a global runtime, but instead have a runtime per atoms. That way they are all isolated and they are easier to test, as you are collocating the actual service implementations with each runtime. This means we're going to get rid of this managed runtime. There's no need for us to have a managed runtime. And we're going to change this to be atom instead of Rx, and then context. And instead of creating our own memo map, we can actually say atom.default memo map. And this, as we can see, is a global constant value, which is effect.runSync layer.make memo map. So pretty much the same thing as we had before. And we are not going to have these global layers here. So we're going to do something different. We're going to call this make atom runtime. And then we can say make atom runtime dot and then add global layer. And then here we can say layer.merge all and then logger.pretty and then logger.minimum log level. And this is pretty much it. So we can now get rid of this main layer and get rid of this runtime. So this is all we need. So I'm going to actually rename this parent directory from Rx to atom, and then Rx utils will in fact be deleted because none of this is necessary. And I'm going to show you what we can do instead. And let's rename this to make atom runtime. Awesome. So now let's update Styles Rx, but for this, we're going to do something different. We're going to move this under root, and we're going to rename this file to styles atoms. And we're going to get rid of this data access directory. Now here, what do we need to do? Well, we need to create our runtime. So we can say runtime, make atom runtime, and then we provide the API client, which means that the runtime will give us access to the API client logically. So this takes a layer. And with this, we can now say runtime.atom instead of runtime.rx, and same for these ones. And as for the registry, we can say atom registry. And we can update our imports where registry comes from artifact atom. And as we can see, the errors went away. But let's actually do one more thing, and that is rename this to styles atom, then upsert style atom, and finally delete style atom. Great. So what does this mean? What are the implications of creating a runtime here? Well, twofold. One, we can now only provide the necessary services. So if we're going to test things, then it's going to be more straightforward rather than having a monolithic runtime. And two, the lifecycle of the runtime. So in other words, the lifecycle of the services will be tied to that of the consumers, which means that if no one uses any of these atoms, maybe you navigated to another page and whatnot, then on destruction, it is going to call all of the finalizers that you specified in your layers. So you can clean up resources and whatnot, which is really, really nice. But if you recall, we're using make atom runtime, which uses a memo map internally, which means that if a lot of different Rx's need access to the API client, then it is only going to construct API client once. It is not going to create one instance per atom runtime, which is a huge, huge plus. Great, so now let's come here to the root page. And we're going to get rid of these imports and our old utils. And what we can do here is say use atom set. There's no use atom promise set, use atom promise exit, just use atom set. But this is going to give us back a function that is going to succeed with void, so nothing, which is not what we want. We want a promise and an unwrapped promise at that. So we can come here to the second argument of the hook and say mode, and then we can specify value, promise, or promise exit. In our case, we want promise. And as we can see, we get a promise of void. Awesome. If we were to do promise exit, logically we get a promise that succeeds with an exit. So let's revert this back. And now we can come here and instead of our old utility use Rx promise, we can say use Rx or use atom. And here we can specify the mode. And in this case, we want a promise exit. Why? Because if I'm not mistaken, if the lead were to throw, then we're going to get a runtime error and potentially crash the application. Unless we have an error boundary and the like, but don't quote me on that. I honestly forgot how React handles errors. And here for use Rx value, well, use atom value. And result now comes from add effect atom. And that's it. That's our whole refactor. Fortunately, we didn't have much, so it is super straightforward. Now, before moving on, let's see if everything still works. So I'm going to refresh my page. Seems like it loaded everything, though pretty much instantly. So let's do something different. Let's come here to our API client, and then we're going to say HTTP client dot transform response, and then we are going to get our response and then say effect dot sleep for now 150 millis, and then we can say effect dot as response, or rather zip right. And by doing this, if I come back here, refresh, as we can see, we get this loading. If I increase this to 700 and then refresh, now that's much better, at least for testing the behavior locally. So now what about deleting? It worked. As we can see, we're not doing any cache writes. We are refreshing everything, so we get that delay. And what about creating? Test, save changes, refreshes, and we get the value here. So awesome, it's working. However, let's do something different here. Let's say effect.function untraced, then get the response here and yield the response. And then we can say yield effect.sleep and then sleep for random dot next range. And then we can say between 100 or 200 millis to worst case 500. And then we can say sleep for, and this is an effect, so we need to yield this. Awesome. So now we can save this, come back here and we should get randomized sleep force. Now you want to make sure to only apply this delay if mvars.effective_env is dev. If not, well, pass through. Now let's take a look at cache updates. So if I come here to the registry and say set, notice how we can pass in an atom and then the new value. However, if you recall, an atom by itself isn't writable. So in effect atom, all atoms by default are read-only. And I guess that's for purity/safety. You need to explicitly define the input parameters to making a writable Rx. So what can we do here? Well, we can actually not export styles atom, but instead rename this to remote atom. And then we can say export const styles atom is runtime dot, or not runtime, but atom dot writable. And here we get access to the atom dot context. So just for reference, this is an atom dot context. And then we can say get and then remote atom. And then for the second argument, we pass in the callback for actually writing stuff. So we can say context, which is an atom.write context of a result. So it infers automatically the return type of this atom. And then you get the new value. So in this case, we're going to call this action. And for now, let's say this will be any. And that's it. Now you can say set or set self and then the new value. What this means is this atom remains here immutable. You can't actually modify the cache of this atom. Everything needs to be derived. So this is what we're achieving here. We're creating a new atom that subscribes to the state of remote atom. So basically a pass-through, but it has its own cache. So when we're writing to this atom, we're actually writing to styles atom, not to the remote atom. Now you can type the action whatever you want, and that's because you get free encapsulation. So in this case, what we can do is say const style or just action, and then data from effect tagged enum. And then here, let me recall the syntax. So it's tagged enum with the t lowercase, and we invoke this by passing in a generic like this. So we can say absurd, and then we can say this will take in the absurd style payload, and then the delete action, which is just the style ID. And we're getting a typer here because we need a tag, but the key should be the tag. So I think I got this the other way around. Yeah, so the type is the one that injects the tag. So we can say data.tagDenum and then absurd and delete, and this will map the tags for us. So the key will be the tag, and then we can replace this with action. And now we can say we take in an action. And as we can see here, we can pattern match against this action. So we can, for example, say action.match. And then we pass in the action and we get free callbacks here with the narrowed down types. So now here we can say const and then result is context.get, and then this would be styles atom, and then we check if not result dot is success result, then return, do not do anything. And now here we can say update is equal to action.match, and then we can say result.value dot filter this style, where style.id is different from this one, but we get a lint error. And that's because this needs to be an object, so we can destructure this directly. And now we can do the same for absurd, so we get the payload here, and then we check ID. If so, result.value.map, and replace the whole entity with the payload. Otherwise, we can actually repend the payload like this. And now we can say context.setSelf and then result.success and then the update. Or in fact, we can say array from effect prepend and then payload to result.value. And I believe we need to say read-only payload to be the subject. That way we can say payload like this. And this is actually self first and then the value. So we can say to result.value the payload. Now we're getting an array of styles or a style or absurd style payload, which makes sense because this is an absurd style payload. So we actually take in a style, not the payload. And that's it. Now we can come here and use the registry like this and then get the result and then say registry.set to styles atom and then we can say action.absurd and then instead of payload we can rename this to style and same here and we can say style will be the new absurd set style. And for delete we can apply the same logic but instead say registry.set to styles atom action.delete and we pass in the ID. And this in theory should work. Though if we take a look at the console, we're getting this warning, executing an effect version 3.17.6 with a runtime of a newer version. So I did update the dependencies, but maybe the Vite server didn't catch that. So we're going to rerun the client and then refresh and we're still getting the error. So let's see at our client package.json, we're using all of the effect dependencies from the workspace, which are overridden at the top level. Okay, so as I was recording this video, they published a new effect version and Team Smart, the author of Atom React, released the 0.1.7 version shortly after. So we were using an outdated version. Anyway, we need to update our root where we now need to access the registry provider from @effect_atom. Now I just had the biggest brain fart. I'm not sure why we're doing this. This doesn't make any sense because again, we're passing in the whole style entity. So this needs to be refactored to existing and then instead of array.find first, we can say result.value.find and then we check if it exists. Then we map over the array. Otherwise, we prepend the style. So now this should work. So if I come back here and then refresh just in case, if I click delete, as we can see, it is now removed from the cache. If I add something, again, it works. And well, we do not support updating yet, so can't test that right now. Now you might be wondering about this pattern. How does this work exactly? What's the relationship? Well, this is a derived atom from the remote atom. So if you think about it, remote atom is the source of truth. It is the one that really dictates what the current state is on the server. Meanwhile, this obviously dictates our modifiable cache, which means that if an error were to occur, for example, here under the root page, if on failure, you were to render a retry component. So retry and then FC, and then you can say something went wrong and then use atom refresh and then you say styles atom and then refresh. And then you were to render a button saying retry. By doing this, and let's actually modify this like such, this is not going to work because you would be refreshing the local cached atom. This is not going to magically trigger a refresh for the parent one, which is remote atom. So you need to actually target this remote atom instead. So what I like to do here is say object.assign and then for the Writable Rx and then provide a remote property which points to the remote atom. That way we can come here and under use atom refresh, we target the remote instead. And that way, once we refresh the remote and it changes for whatever reason, then the remote atom will cause this child, so styles atom, to react to those changes. And this is pretty much it. So now moving on from this, since this is now pretty much done, you might be wondering about this runtime pattern. What about services that should not be destroyed? Well, what you can do is add your root. So here, this is not a component. So we can create a keep alive services.ts or tsx actually. And then you can say export const keep alive services is a react.function component that returns null. And here you can say use atom mount, and then you can create the keep alive runtime. So make atom runtime and then worker client dot default, and then you just mount the runtime like this. And now you can ensure that here the services that you consume here will never be effectively destroyed unless, well, the root itself unmounts. So by doing this, if I refresh, as we can see, we get worker started. And no matter what, no matter where the user goes to, where the user navigates to, this runtime will be there forever. Now remember, this uses a memo map internally. So if I were to come here to styles atoms and then do a worker client dot default, and this is actually a layer dot merge, and save this, and then come back here, we only get one worker started. And once this runtime reaches its end of life because there are no consumers, then it is going to dispose of API client, but well, worker client will not be disposed since there's another consumer, another reference for that layer. Anyway, this wraps up the video. If you have any questions, feedback, whatever, do let me know in the comments. I'll see you in the next one. See ya.